a very good day to our Dr. Adina Najwa Kamarudin and my fellow friends. We are from Group 1 and the tablet assigned to us is Pil Lajak Kuruwe A. And here are our officers, which is Remini, anak perempuan Martin Benjamin, Zulkifli bin Maidin, which is my own self, Dewa Tashini, anak perempuan Vid Tamila Resu, and also Shaktish, anak laki Murugaya. And we are the officers which is in charge to monitor the tablet Lajak Kuruwe A production. So our first task, which is task A, to describe and summarize the sample data of your assigned Lajak Laku tablet, which is Lajak Laku tablet product A, produced in December 2020, and we need to present the observation effectively in numerical, tabular, and graphical forms. So this is a sample data tablet A, which is total 200 samples. And morning, evening, and night, we have arranged it accordingly, which is 67, 77, and 56. And this is the pie chart form where we show in terms of percentage, where we can see that evening produced the highest sample data of Pilajat Kuruwe A. And next, the summarization that we have done based on weight only. And here are the numerical form of it, where we can see the sum of weight is 69944.15. The average of weight is 349.72075. The variance of weight is 191.6225497. And also standard deviation of weight, which is 13.8427797. We also have shown to everyone here right now the sum, average, variance of, and standard deviation of weight for each shift, which is morning, evening, and night, to be more accurate. And here we have summarized the important details that should be seen, which is total, the mean, median, maximum, variance, standard deviation, median, and also the mode. And here we have arranged accordingly, which is in the interval of 10. And also here are the frequencies, which is going to accumulate to 200, which is the total sample data that are given to us. The graphical form of summarization of the weight, where here the average of weight, we can see the evening is the highest. The sum of weight on the evening are also the highest, which is 2694.9.87, and the weight of tablet produced, which is in the range of 350 to 360, are the highest, which is the 58. So next are the summarization based on relative density. So we can see here the sum of relative density is 17605.9, the average of relative density 88.0295, variance of relative density, which is 4.106411.809, and also standard deviation of relative density 2.02642838. And here are the relative density, important details, total, mean, minimum, maximum, variance, standard deviation, median, and the mode. And we have arranged accordingly of relative density in the interval of 1, and here are the frequencies of it, and which is going to total 200. And here are the graphical form, which is the sum of relative density. Here we can see evening produces the highest amount of relative density, sum of it. And here we can see also evening produces the highest sum average of relative density, which is 88.063636 and 36. And relative density of table produced in the range of 87.7 to 88.7, which is produced the highest, which is 37. And next, we're going to talk about summarization based on tensile strength. Here we can see the sum of tensile strength, average, variance, and also standard, where the sum of tensile strength is 1428.9, average of tensile strength is 7.1445, the variance of tensile strength 0.0350449975, and standard deviation of tensile strength 0.187203031. And here are the tensile strength details, the important one, as I said just now, total, mean, minimum, maximum, variance, standard deviation, median, and also the mode. And we have arranged the tensile strength accordingly from the lowest to the highest, and here are the frequencies of it, and total are 200, which is the total sample of data, as it should be. And here are the graphical form of it. Sum of tensile strength in the evening still the highest, the average tensile strength in the evening still the highest, and the tensile strength in the range of 7, tensile strength of tablet, which is 7.2, produces the highest, which is 42. And some types of shift. So here we can see the sum of type of shifts is morning, evening, and night. We have arranged accordingly to sum of the weight, sum of the relative density, and sum of tensile strength, where we can see evening have the highest sum of weight, the relative density, and also tensile strength. Here are the average type of shift, where we can see we do arrange it accordingly to morning, evening, and night, and evening still have the highest average of weight, average of relative density, and average of tensile strength. So that's all from me. Now I'll proceed to my friend Shakti and Akimurugaya for the task B. Thank you.
Hi, my name is Shakti. Next, we're going to analyze the table meet the requirements stated by Food and Drug Administrative FDA authority. This analysis we're using goodness of fit test. Goodness of fit test used to test if the data follow particular distribution. In our case, we want to test the table follow normal distribution, which mean is 350 milligram, and also the standard deviation of 14 milligram. Using chi-square test statistic, which summarize the discrepancy between observed value and the expected value. The lower the discrepancy, the higher the fitness. Next, we move on to the hypothesis statement. Our null hypothesis is the data follow normal distribution with mean 350 And our alternative hypothesis, the data do not follow the normal distribution with mean 350 and below is our normal distribution. Let's see our test statistic. First of all, we have to know the range of the weight, and next we have to calculate the probability, and don't forget our total should be 200. Next, we move on to our frequency, and also don't forget our frequency total should be 1. Then we have to calculate our expected value by using the formula E equals to NP, and the total value of expected value also must be 200. And we get to know that our expected value have value that lower than 5. So that means we have to calculate back and we have to find our new O prime and also E prime. And also don't forget our O prime and E prime should be 200 in total. Then our chi-square test is equals to 2.6396. Next, we move on to our decision rule. Our significance level alpha we use is 0.05. Our degree of freedom is 5. And also our critical value for chi-square 0.055 is equals to 11.0705. And our decision rule reject our null hypothesis of chi-square test is greater than 11.0705. Next, our conclusion for our goodness of fit test, since our chi-square test 2.6296 less than chi-square 0.055 is equals to 11.0705, thus not enough evidence to reject our null hypothesis. We conclude the data is following the normal distribution based on requirements with 350 milligram mean and 14 milligram standard deviation. And that's all from me. Thank you.
Hi everyone. So now me, Remini Martin, will proceed with the next part of our project, which is the task C. So in this task C is regarding the comment on whether there is any significance difference between tablet weights from the different shifts. Okay. So basically we're going to use ANOVA here. So as you all know, ANOVA stands for one-way analysis of variance, and also it is used to test the equality for means of 3 or more population. Alright, as you can see there, there's 3 kind of shifts, which is morning, evening, and night, and the given data such as the count, sum of weight, average of weight, and variance of weight. And below is the ANOVA Excel output, which covers the source of variation, sum of squares, degree of freedom, mean squares, F-test, p-value, and F-critical. Alright, now I'll proceed with the next part, which is the hypothesis statement, whereby we have constructed 2 null hypothesis statement. H0, which is mean 1 equals to mean 2 equals to mean 3, and H1 is at least one of the mean is different. Alright, now it is the decision rule, whereby it consists of the significance level alpha, which is equals to 0.05, number of populations, k equals to 3, total samples, n equals to 200, and using all these values, we will find the critical value, which is 3.0418. Okay, moving forward is the decision rule, whereby if F-test 0.05398 is greater than F-critical 3.0418, therefore the H0 will be rejected. However, since F-test 0.05398 is lesser than F-critical 3.0418, therefore, we do not have enough evidence to reject H0. And now, finally, is the conclusion, whereby we can conclude that there is no significant difference exists between tablet weights from the different shifts. So that's all from me. Now I'll pass it on to my teammate, which is Deva Tarshini. Thank you.
Hello everyone, I'm Devadarshini Anapurupan V. Tamarasu and will explain about task D. So for task D, first we need to determine whether relative density and tensile strength have linear relationship or not. Second, we need to predict the tensile strength for given relative density values. Third, we need to comment on validity of the model that you have used to carry out this prediction. Next, this is the summary output for regression statistic where it contains multiple R and other values. Next, we need to determine the variables. So, relative density is independent variable, whereby tensile strength is dependent variable. So, the Persian coefficient is equal to 0.857282964787818. So the multiple R is 85.73%, which shows there is a correlation and acceptable fit. Next, this is the output for linearity of regression from Excel, where it contains sources of variation, regression, residual, degrees of freedom, sums of square, mean square, F-test, and F-critical value. And also it contains alpha and beta values. We move on to regression testing. So first, we need to state hypothesis statement. So for null hypothesis, beta equal to 0. For alternative hypothesis, beta unequal to 0. Next, alpha is equal to 0.05, k equal to 2, n equal to 200. Critical value is we got from the Excel output. So for decision rule, if F test is more than F critical value, hash not will be rejected. Since F test is more than F critical value, thus we have enough evidence to reject hash not. So we can conclude that tensile strength and relative density have linear relationship. Next, checking model assumption. So this graph represents the normal probability plot where the x-axis is sample percentile and y-axis is tensile strength in megapascal. Next, this graph represents the relative density line fit plot, whereby the x-axis is relative density in percentage, y-axis is in tensile strength in megapascal. So this graph contains two information which are tensile strength and predicted tensile strength. So this color represents the predicted tensile strength and this color represents the tensile strength. By looking at this graph, we can say that it has positive linear slope. Next, for linear regression equation, y equal to alpha plus beta x. So when we substitute the alpha and beta values from the Excel output, we will get the regression equation. So next, for prediction, we need to predict the tensile strength from relative density values. So we substitute these values in x. So we'll get the tensile strength here. So these are the values of tensile strength. The prediction made is not valid because the value of relative density which we do the prediction is not in the range of 83.7 to 92.9. So this is the range of the relative density from given data. That's all from us. Thank you.